It's early morning in Phoenix, Arizona. Southwest Airlines engineers are continuing their scheduled maintenance of a 737. Southwest is unique among larger airlines. It flies just one kind of plane, the 737. Tonight, engineers are working on a 700 model, one of the newest 737s. But the company's very first 300 model, bought in the mid-1980s, is still flying.
You can still operate an old airplane as long as you have inspection protocols. When you look at some of the cargo carriers, they're operating airplanes that are 30 and 40 and even 50 years old. They're still reliable airplanes. They've been maintained, they've been retrofitted with modern-day equipment.
Updating older planes is a standard part of maintenance. But sometimes installing a new component in an older plane can lead to tragedy. Inside this makeshift lab are the shattered remains of Swissair Flight 111. On September the 2nd, 1998, the passenger jet crashed off the coast of Nova Scotia, Canada, killing everyone on board. Recovered from the seabed, the debris is overwhelming. There is almost 250 kilometers of wiring alone.
In Swissair, we've had about 2 million pieces of airplane, and we pretty much almost had to look at them all.
In the business, we refer to often finding the golden nugget. That's saying, aha, there's the cause of the accident.
Somewhere in this wreckage, investigators hope to find that golden nugget. The one piece that will reveal the reason why Swissair 111 crashed into the Atlantic Ocean. The cockpit voice recorder gives investigators their first critical clues.
Do you smell something?
Yeah, what is that? Go have a look, I'll take the controls.
Roger, you have control.
The first officer checks the area around the air conditioning vent. Nothing seems wrong.
I don't see anything, Urs. And there's nothing up there now.
Captain Zimmerman is troubled by the smell of smoke.
There it is again.
He starts to divert the plane to the nearest airport.
Find the closest place to land, Stefan.
He radios air traffic control in Moncton, New Brunswick.
Moncton Center, Swissair 111 Heavy is declaring pan, pan, pan. We have smoke in the cockpit.
Pan, pan, pan is an international term used to notify air traffic control of an urgent situation.
30 miles to fly to the threshold.
It's one step below declaring Mayday.
I guess Boston, we need for...
Swissair 111 is directed to Halifax and starts its descent.
Okay, can I vector you to set up for runway 06 at Halifax?
The pilots appear calm and in control. Halifax is just 20 minutes away.
They want us to turn to the south.
At that point, everything was normal. I gave the pilot an initial descent, and he requested to level off at an intermediate altitude to get the cabin in order for the landing, which took to mean that they needed to pack away dinner trays and things like that.
Cabin bus off! Cabin bus off, roger.
But the seemingly controlled situation on board Swissair Flight 111 escalates into a full-scale emergency.
Autopilot, disconnect! We are declaring emergency now, Swissair 111 at time 0124. All my screens are down. I'm flying on standby instruments, maintaining 300.
Shortly after declaring an emergency, the plane goes silent.
It was probably one of the most helpless feelings that any individual can have, not being able to do anything but just sit and watch the target and hope that it would turn back toward the airport. And of course it didn't.
At 10:31 p.m. Atlantic time, residents of Peggy's Cove hear a devastating explosion. From the cockpit voice recorder, investigators know they're dealing with a fire and not a plane that was malfunctioning.
We found no anomalies or no problems in any of that flight data that suggested there was a problem with the aircraft.
Investigators work their way through the hangar of wreckage recovered from the Atlantic Ocean. Finally, they find scorch marks, which reveal that the source of the fire was in the back of the cockpit, directly behind the first officer. Following this trail leads the team to an unlikely suspect, the entertainment system in first class. The Swissair MD-11s provided first class with one of the world's most sophisticated entertainment systems. Passengers in first class could choose their own movies, access the internet, and even gamble. This entertainment system was not part of the original MD-11 design.
The system had some major deficiencies. It was getting very hot. It drew a lot of power. And thereby, for example, raising the cabin temperature considerably, because it was always running. They did not install a simple off switch, nor did they install appropriate cooling systems.
Anytime you have an electrical system or you're putting an aftermarket install into an airplane, you run the risk of compromising the integrity of the aircraft itself as it was originally designed.
When informed about the flaw in the wiring, Swissair immediately disabled the entertainment system on the rest of its fleet. But investigators discover that another piece of the jet had helped the fire spread with alarming speed.
And in this instance, we did discover a wire that arced in that way, and right next to it was some very flammable material called metallized polyethylene terephthalate covering material that covers the insulation blankets.
This polyethylene insulate was common on commercial airlines around the world. It had somehow passed the industry's flammability tests, which require materials to self-extinguish after a reasonable period of time.
This thermoacoustical material that was in this aircraft was very flammable, even though it passed a test. It does sustain and it does propagate flame.
The fire spread quickly from the cockpit back into the first-class galleys. Some metals showed heat damage from temperatures as high as 1100 degrees Fahrenheit. Less than 12 minutes after the crew declared a pan-pan, the fire disabled all electronics in the cockpit. In the aftermath, Swissair removed the flammable insulate from its entire MD-11 fleet. The rest of the industry was required to follow suit. In Phoenix, Arizona, flight engineers continue their C-check on the 737. It includes testing the plane's rudder. The rudder is one of the jet's most vital control surfaces. It allows a plane to turn left and right.
Okay, CBS, rudder should turn. All right, go ahead. There you go.
A problem here could have terrifying consequences.
You're clear on the left.
In fact, despite years of proper maintenance, a problem with a tiny component with the 737 rudder killed more than 100 people. Not even the most diligent maintenance workers could have spotted it. March the 3rd, 1991. United Flight 585 begins its final approach into Colorado Springs.
Another 10-out gain.
30 flaps.
Oh, God, sick!
15 flaps.
15!
Going up.
Oh, my God! Oh, my God! Oh, my God!
All 20 passengers and 5 crew are killed. Investigators from the National Transportation Safety Board descend on Colorado Springs.
My first sense that it was going to take some time to investigate the accident was the damage that we saw in the parts.
An aerospace engineer by training, Greg Phillips is in charge of investigating United 585's flight control systems.
We focused in after eliminating other flight control surfaces that we thought could contribute to the role. We started looking at the rudder.
But investigators face a critical obstacle. Most of the plane's parts are too crushed or burned for testing. Luckily, one vital component is still reasonably intact. This is the Power Control Unit, or PCU. Used constantly during flight, especially during landings, the PCU performs like a car's power steering. When the pilot pushes on a rudder pedal, the PCU uses hydraulic fluid to convert the gentle movements of a pilot's foot into the pressure needed to move the 737's enormous rudder. The heart of the PCU is the dual servo valve. This valve is roughly the size of a soda can. It contains 2 extremely thin slides that glide past one another. These slides direct the flow of hydraulic fluid which moves the rudder. When a technician opens up the power control unit, it seems to be in working order.
We didn't have any absolute indication or information that we could point to that said the rudder power control unit, the servo valve, or any part of that flight control system caused that accident.
It's a pass.
For only the 4th time in its history, the NTSB releases a report that does not reach a conclusion.
We had put a lot of time and effort into the investigation, and we just weren't sure what had happened.
Less than 2 years later, Greg Phillips and the NTSB would be brought back to the mysterious disaster through the crash of another 737.
Hold on, hold on. Hold on. Shoot! What the hell is this? Oh, God, no!
September the 8th, 1994. US Air Flight 427 has crashed near Pittsburgh, killing everyone on board.
When we first arrived at the crash site, first of all, there was no aircraft there. There were only bits and pieces of the airplane. It wasn't really recognizable as an airplane.
Investigators begin to see that this crash is a mirror image of United Flight 585. On final approach, United 585 rolled right, while US Air 427 rolled left. Both crews are caught by surprise. After a terrifying struggle, both crash with no survivors. Once again, investigators test the dual servo valve, but they come up empty-handed.
That unit passed all its operational tests. There wasn't any indication that it had failed.
We were going up against an aircraft that had an incredible safety history. It was really everything you could see for 30 years. This has been a great airplane. We were trying to prove that there was something wrong with the straight-A student.
The team reaches another dead end. But almost 2 years later, they get a third chance to solve this deadly mystery. In Phoenix, Arizona, a long night of maintenance is winding down. Over 30 mechanics and some half a dozen inspectors have combed through a Southwest Airlines 737. The team has made more than 400 separate checks. Parts have been replaced. Southwest 737 N427WN is almost ready to fly again.
Hopefully it'll push back out of the hangar. We'll do some leak checks, make sure everything's working, nothing's leaking. Then it'll go to the gate for departure time.
But it's a truth in maintenance that engineers can only fix what they know is broken. For several years, every 737 that flew had a hidden danger that not even the most careful technician could have spotted. In the early 1990s, two 737s crashed in mysterious accidents. In both cases, the jets spiraled out of control. In 1996, the same malfunction strikes again. It's June the 9th. Captain Brian Bishop prepares to land in Richmond, Virginia. Then, just like United 585 and US Air 427, his plane rolls out of control.
I turned the yoke the opposite direction and stood on the opposite rudder pedal. The pedal didn't move for me. We didn't know to what extent, but we knew we had a problem with the rudder.
For over 30 seconds, Bishop struggles to control his renegade plane. And then, just as suddenly, the 737 calms down and goes back to horizontal.
We had started the checklist. Almost before I could finish the sentence, all of a sudden there was just a wham.
The 737 is once again out of control. Then, out of the blue, East Wind 517 is back on track. Wasting no time, Captain Bishop gets it onto the tarmac.
Taxiing in is when I realized my legs were shaking.
We launched to the scene. The airplane literally didn't move, stayed at its location in the airport until we got down there.
Suddenly they had a 737 that had had a rudder incident that was intact, and they had a pilot who was alive and who could talk about it.
I think they were much happier to have the airplane than me.
Investigators zero in on the 737's rudder controls. The power control unit is tested again and again, but it performs perfectly. Refusing to give up, investigator Tom Houter decides to try a different test.
One fellow mentioned a test they had done in the military of a thermal shock.
The power control unit is soaked in dry ice and blasted with nitrogen gas at -40 degrees Celsius. Then it's injected with superheated hydraulic fluid. It's then given a command to start working.
As we were standing there listening to the actuator move left and right, it stopped. And it was not commanded to stop.
It just jammed. Stopped working completely.
The team has discovered that a small hydraulic valve that controls the rudder of the world's most popular jetliner can jam in the right circumstances. And the valve can jam without leaving behind any traces. When investigators double-check their results, they discover another major flaw.
Careful analysis of the data, a couple of the engineers recognized that it not only stopped working, but actually left became right and right became left. There was actually a movement of fluid into places that it shouldn't have gone.
And the reversal is like driving your car. You turn to the right, it goes left. You're not going to figure out this failure mode until you go off the road. And in these cases, that's the pilots were faced with something so unusual that they didn't understand what was happening.
What the hell is this?
That would explain why the first officer, Chuck Emmett, would keep his foot on the rudder pedal, because he's thinking, why isn't the plane going right? And he's feeling the plane go to the left.
In the aftermath of these disasters, pilots received better training on how to deal with sudden rudder problems. Boeing spent hundreds of millions of dollars redesigning and replacing the rudder's dual servo valve on thousands of 737s around the world.
One thing we don't like at the safety board is to have an undetermined accident, because then we can't make a change to improve safety. So out of US Air 427, United 585, we have a much safer 737 fleet.
It's 7 a.m. After an 8-hour shift, the maintenance is finished on this Southwest Airlines 737. According to their maintenance reports, the team has conducted 78 unscheduled procedures and 339 scheduled inspections.
I think each one of us out here has a sense of pride in themselves that we do the best job that we possibly can day in, day out. Obviously, the stakes are high. Every life is important.
Despite the horror of airplane disasters, they're still extremely rare, especially given how often passenger planes take off and land.
Sometimes we obscure the fact that we fly millions and millions and millions of people day in and day out without putting a scratch on even the airplane, let alone the people. This is the most amazing system.
This system depends on the dedicated team of professionals committed to taking care of these 21st century masterpieces. Planes so well built that they could fly almost as long as we're willing to take care of them.
We've learned now how to inspect and maintain these things and even rebuild them to where they should have an indefinite life. They're built tough and they should be able to last forever if they're maintained properly.